Okay, so 5.4 is all about the fundamental theorem of algebra. So I might abbreviate it as FTOA. So it's going to kind of combine an idea that we introduced in Unit 4 graphing. Okay, so the fundamental theorem of algebra, it was proved by Carl Gauss in 1799. So think about how this has been around for over 200 years. Somebody knew about this. So what it says is if you have a polynomial, and we're talking about quadratics, but this can be used with any degree. So you're going to see this again when you get to Sec 3 if you take that class. Basically, if you can write it in factored form, we know that the factors, if we set them equal to 0, those are called the roots. Remember, roots, solutions, zeros, x-intercepts, all meant the same thing. Okay, so what it's saying is that when you set an equation equal to 0 and you solve, you're really finding those roots. We did that back in the graphing unit of quadratics in Unit 4 this quarter, okay? So there are some scenarios. There's 3 scenarios that can exist, okay? So the first one is when we had 2 roots. So let's just say when I solved my quadratic, I had the factors f of x equals x plus 3, x minus 1. And so we would take those factors, set them equal to 0. So add 1, subtract 3. And so remember, our roots were the opposite sign of the factors. So that means at -3 and at 1. And then I would have a parabola. Remember, my vertex was exactly in the middle, but I'm just going to eyeball this, okay? And so I could have 2 real solutions. All right. My second scenario is, let's say we had a polynomial like f of x equals x squared minus 2x plus 1. If we factored this with the AC method, I'm just going to do it to save time, we would end up with x minus 1, x minus 1. And so we have the same factor twice. So if we set the equation equal to 0, add 1, so x equals 1 is a root. Okay, and so what happens is it only touched the x-axis one time because we call this a double root, okay, or multiplicity of 2. Multiplicity is the technical word for double. All right, and then the last scenario, and we haven't really talked about this in the last Unit 4, is what if I was given something like x squared plus 4. Well, if I take x squared plus 4 equals 0, I can subtract 4. We just learned how to solve this in the last section. Then I can take the square root. So I get x equals plus or minus. Well, I have a negative here, so I get I. And 4 breaks down into 2 times 2, so there's a double. So I get plus or minus 2i. And so what happens is, since this is imaginary, this is a real axis, so I'm not going to see this cross anywhere. So we end up with a parabola that doesn't ever cross the x-axis. So I forgot to write this here. 1 real solution. And so what this means is we have 0 real solutions. And so what that really meant was we had 2 imaginary solutions. Okay, so those are the 3 scenarios and kind of the algebraic reason to why would I have 2 answers, 1 answer, and no real answers. Okay, so another way for us without having to factor and make tables and solve is to find a value that's called the discriminant. So the discriminant should look familiar. Remember, this is the quadratic formula. The negative b plus or minus the root of b squared minus 4ac all over 2a, quadratic formula. The discriminant, though, is only the part that's under the root, and it does not include the root, okay? So what happens is if we only find the discriminant value, we can predict how many solutions our quadratic is going to have. So if we do b squared minus 4 times a times c, and we end up with a positive number, because it's greater than 0, so I'm going to write the word positive, that means that there's going to be 2 real solutions, like scenario 1. If we do our discriminant and it equals 0, well, that's when our double root happened. We get 1 real solution. And if we get b squared minus 4ac and it ends up as a negative number, then we have no real solutions. You don't have to tell me it's too imaginary. I want you to understand that there are solutions, but they're imaginary. So that's why we had to learn imaginary numbers first, okay? So now, the only drawback, though, is that this will only tell you the type of answer, okay? It doesn't find the actual answers, okay? In order to do that, you would need to solve or factor, okay? Now, the key to the discriminant is you want your answer in standard form, which is ax squared plus bx plus c. So you need all 3 terms, and you want values so you can plug it into the discriminant formula, okay? All right, so let's practice finding the discriminant. So on the first one, well, remember, f of x is the same as y. I don't have any terms to combine, and it looks like it's in order, x squared, x to the first, and the number. So a is 3, b is 9, and c is 1. So this says state the discriminant value and classify the types of solutions. Notice how I don't say find the solutions. So we get b squared minus 4 times a times c. So b is 9 times a times c. Now, I do want to see this on your student practice, but once you have the formula written, you can really just type that into a calculator. So I don't have one in front of me, so I'm just going to write it out. I get 81 minus 12, which, let's go ahead, I'm going to use a window. So 81 minus 12, I don't want to make a mistake. So I end up with 69. All right. Now, that's my discriminant. And so what we need to figure out is our classification. So since that's a positive number, I get 2 real solutions. So 2 real solutions. Okay, and I want both parts. I want the discriminant value, and I want the type of answers that we would have if we solved, but we're not solving. All right, let's look at example number 2. So this one is in that parenthesis. Now you can't just square this, so it is going to take us a little bit of work. What that squared means is I actually have 2 of this parenthesis. Okay, I promise you if you just squared those 2 numbers, it will not work out. Okay, if there was a shortcut, I would totally tell you about it. So I'm going to leave the 2 alone, and then we're going to multiply these 2 parentheses. So we learned that in Unit 1. So as a review, we do x times x. Remember, when it's x to the first times x to the first, you add exponents. So you get x squared. Then x times negative 3. Then negative 3 times x. And then negative 3 times negative 3. Okay? And I still have the minus 8. All right, so that's my first step. Write it out twice. Do the multiplying of the parentheses. Then I'm going to distribute the 2. So we get 2x squared minus 6x minus, remember you multiply, 6x plus 18. Once you've distributed, you don't need the parentheses, and then I get minus 8. Our last step is to combine like terms. So this is my only x squared. We can add these together. So negative 6 minus 6 is negative 12. And then we can add these together. 18 minus 8 is 10. Okay, so now all I've done is write my vertex form in the standard form, which is what we need to find the discriminant. That's how we would do the quadratic formula. So A is 2, B is negative 12, and C is 10. So our discriminant is b squared minus 4 times a times c. So because this is a negative, you do need to use parentheses in a calculator. A is 2 times C. All right, and I'm going to just type that straight in. So I get negative 12 squared minus 4 times, I'm going to look back, 2 times 10. I ended up with 64. That's my discriminant. Okay, and since that's positive, I have the same thing as my first example, 2 real solutions. All right, so most of the work was to get it in standard form. All right, let's look at my third example. So this one, I don't need to do any multiplying, but I do need to get all the terms to one side. So it doesn't matter if you move things to the left or the right. I just looked that I have 2 on the left and 3 on the right, so I'm just going to move these to the right side, just a preference. So I'm going to add 7x, and I'm going to line it up with the other x term, and add 17. So 0 equals 4x squared plus 20x plus 25. So here's A is 4, B is 20, and C is 25. So for our discriminant, we get B squared minus 4 times A times C. So 20 squared, 4 times A times C. And I'm going to type that into my calculator. So I get 20, since it's positive, I don't need the parenthesis, minus 4 times A times C. So I ended up with 0. So now I need to remember, well, it's not positive. So if it equals 0, that's when we had that multiplicity of 2, the double root. So we get 1 real solution. Okay, so make sure you have the right values for A, B, and C. Make sure you're typing them into your calculator correctly, and then trust your discriminant value. All right, so go ahead and try your practice and let me know if you have any questions.